Now Chris is going to be talking a bit about cool water species, some of the more native species that we're used to here in the Midwest, and I'll just turn it over to him.
Great, thank you. So basically I'll kind of pick up where Steve just left off and talk about some of the other types of production systems, and then as Don just said, transition over to some of the more regional species. So really, if we take a look at this, a bit of what Steve was talking about is if you have intensification on the x-axis there, essentially you have production on your y-axis. And a lot of what Steve was essentially talking about here is in the upper right-hand side. Kind of what I'm talking about is in the lower left to get us started. And that is ponds. Right? It's not something to be ignored. Ponds overall, that's the #1 production system worldwide, #1 in the US, and #1 in the upper Midwest as well. So there's still room and capacity out there to do pond culture of fish. What are the differences between that and, say, a recirculating aquaculture? Is generally they're raised at low densities, more natural, therefore less stress, and that results in an increase in growth. A couple of things to keep in mind is they frequently have fish farmers getting started in Wisconsin, and they like the idea of ponds, and I say to them, well, what's your source of water? And they'll be like, well, I'll dig the pond and it'll fill up and I'm set. And I always say to them, no, you're going to be draining and filling and draining and filling that pond. You need to have a water source. So is it surface water or well water? In Wisconsin, you're going to have to go primarily with well water. It's almost impossible to divert any surface water at this point. Another nice thing about ponds, though, is that the effluents can be contained within the pond. But this again comes back to the fact that you'll frequently have to drain those ponds, dredge out a lot of those effluents or solids that are there to get the pond back into production again. In terms of economics for ponds, they're fairly inexpensive to build. Probably what has more to do with it is what's the soil that you're building the ponds in. Generally, you want a 10 to 20% clay in your soil in order for them to hold any water. But a couple of farms are now going over to lined ponds instead. And there's some benefits and disadvantages to that. The cost goes up drastically if you add a liner to your pond. On the other hand, you're now basically treating that pond almost like a tank, and you control everything that's going to be going in and out of that tank. There's a picture here. This is actually the Wild Rose State Fish Hatchery in Wisconsin. They went with lined ponds. The manager actually just retired, and he can tell you that they spent 2 years after it officially opened trying to get these lined ponds into operation. They had everything from tears to bubbles getting trapped underneath to freezing happening and rips and tears. So it took an additional 2 years after their construction was done to actually get fish into those ponds to get past that initial problems that they had. As Steve just mentioned, actually, what is the downside to ponds? Well, you're relying upon seasonal growth. And I think Greg actually was whispering in my ear when Steve had up there saying they freeze in winter. No, they freeze in fall, they freeze in winter, and they freeze in spring. You're not from the upper Midwest, so you're only going to get about 120 to 200 days of growth out of your fish in those ponds. And therefore, what you often find is if they're raising these as food fish, that's at least a 2-year production cycle to get most of these fish to the point of harvest. On the other hand, if you're raising stockers, they can usually do it in 1 production cycle. I also mentioned the fact about you need suitable property, and I put up there permits. Wisconsin, as far as I'm concerned, is a highly regulated and permitted state, and they have permits that are basically applied whether it's a natural or artificial body of water. Did you dig the pond, or was it there already? They also have debates over who owns the land and the water. In Wisconsin, and I always find this just to be kind of ridiculous, aquaculture, fish farming, is not considered agriculture. Right? It's not considered farming in Wisconsin, even though it's in the name fish farming. Right? Because of that, we have the Department of Agriculture that regulates the animals, the fish that are in the ponds. We have the Department of Natural Resources that regulate the water that are in the ponds. And if you ever want to touch the soil underneath it, you usually have to get the USGS involved, or the Army Corps of Engineers, to weigh in on whether you should be able to dredge that pond. Steve was talking about discharge. At some point you're going to have to drain those ponds. Where's that water going to go? There's land application for it. There's wetlands that can go into it. But as we've heard, they're going to regulate and monitor the amount of phosphorus in there, and that's becoming a bigger issue. And then we also have issues in our state about public access. And that is, if you dug a pond, you put water in it, you put fish in it, in Wisconsin, the water is owned by the people, and therefore the people should be able to come and fish your pond. Even though it's on your property and you've dug it, they can still come there and potentially fish that pond. So they have to have regulations regarding public access to these bodies of water. As I mentioned, people often think of ponds as these static environments to grow the fish. And it's one of the first things I tell these startup businesses is, no, you're going to be basically managing and changing that pond quite frequently. You're going to have periods of the year where you're going to have to fill it. When you do, a lot of nutrients are going to be released. This is going to increase the biological oxygen demand, and it's going to change things such as alkalinity, pH, and phosphorus within the system. At certain times, you're going to have to drain those ponds. So they should be designed properly with catch basins or different types of traps where the fish actually go into those areas instead of getting trapped in the mud at the bottom of those ponds. So they're a lot more hands-on and managed than most people actually believe when it comes to ponds. And then finally, you have to talk about the management. What happens once the water is in there and the fish are going in? Aeration is common, especially during the summer times, but even if you're keeping the fish in the ponds in the winter, you're going to have to aerate it to make sure that it stays open so oxygen can get in. And then there comes the whole concept of fertilization. A lot of the growers, you'll see this as I go through some species, they put the fish in the springtime, the larval fish, and they fertilize them because they want to establish food chains. I often spend a lot of talks at different organizations or new producers and talk about inorganic and organic fertilizers and the pros and the cons for it. They don't usually realize that inorganics establish an autotrophic food web based on algae, and it's kind of a rapid, predictable response, but it's short-lived. Organic fertilizer, really inexpensive, establishes two types of food chains. One's an algae-based, one's a bacteria-based, but it's more for long-term enhancement. So I try to convince a lot of these growers that really what you want is a kind of a combination of the two. Get that initial surge so that you get a food chain established for your fry, and then essentially keep it going for as long as those fish are going to be in that pond. Now, a couple other kind of outside of that I wanted to talk about. We've been mentioning the term aquaponics. It's got a lot of pros to aquaponics in terms of that it's an integrated system. It's soilless for your plants and your fish. Right? It's free of biocides. I try to tell all the people that I kind of give them some information about aquaponics. Pick up a bottle of any type of insecticide or plant treatment chemical and flip it over and read the fine print, and it says not safe for aquatic systems. Just like turn over any pharmaceutical or bottle of something you apply to fish, and it'll all usually say on it will kill plants. So basically aquaponics is a system where you can't add any of these biocides into it because it kills one of the two main crops that you're raising. It's a conservative use of water, space, and labor, pretty much because everything's done in a very compact, high-density system. So you can usually fit in more plants per square meter than you could if you did this out in a field. Overall, one of the positive aspects people like about it is that you're growing both a vegetable and a protein crop. This ties well in with what people talk about as a food safety. You're controlling all the food that you're going to eat right out of that system. Up around here, you're going to be doing this in greenhouses or indoors, and therefore it's a year-round production system. I forget if somebody had the slide that said it's 1,500 miles for your food to travel. Right? Here, one of the things people like is that you can literally go into one of these greenhouses any time of the year, and there's a crop ready to be harvested. People often ask me, when do you spend most of your time in the greenhouse? And I say usually January and February. Because it's 80 degrees, it's sunny, and there's fresh corn growing right in front of me. Right? They also say that aquaponics meets some socioeconomic challenges. One of the largest groups that kind of makes aquaponics popular is the urban movement. Right? People like this idea of growing crops right in the downtown parts of cities or the reclaimed parts of industrial sections of cities. I will point out that if you look at any of the surveys that have been done of aquaponics, most aquaponic operations are either in peri-urban, that is suburban or rural areas. So while the media really likes the urban aquaculture, urban aquaponics movement, most production doesn't actually happen in big cities. Right? It's just, it adds to people's enthusiasm about aquaponics. And then we heard earlier today too, the locavore movement is really high right now. People like the idea that their produce is right around the corner. I frequently have people come in and they'll say, well, I want some lettuce and I want some fish. And I'll say, oh, do you want to pick it out? And they'll be like, oh, I'd love to pick out which one I want to have now. And I'm like, well, that's $1 extra. but go ahead. Right? So they point to a head of lettuce. They don't even know later on I pick out a different one, but hey, they think that they picked out what they like. We often refer to it as the red lobster concept, where you pick out that lobster from the tank as you go into the restaurant. I can almost guarantee you that's not the lobster that you get served by the time it comes to your plate. But people like the locavore movement. On the other hand, aquaponics still has a lot of obstacles to overcome. Initial costs, including loans and financing. I frequently get calls from different financing agencies saying, this person's come to me with their business plan, they want to launch an aquaponics operation, they weren't able to provide it, can you give me 3 to 4 other examples of similar size that are producing and making money? My answer is always the same, no. Not very good for that operation. But there just aren't that many examples that are out there. And which we'll talk about a little later as well, is that every one of these operations for aquaponics is unique. There's something a little different about everybody's operation. So it doesn't provide that consistency that the loan agencies are looking for. Location is another big issue. I mentioned urban aquaponics, right? It's a nice concept, except that it's considered agriculture, and cities are not zoned for agriculture. I know for a fact, I'm sure it happened in Minneapolis as well, but Chicago and Milwaukee went through long periods of time where they had to get the city councils and the different representatives to rezone vacant lots so they can do agriculture in them. And in some cases, it took years for that process to go through. So that's something to keep in mind when you're deciding where to place the operation. This one here is kind of my favorite saying, and I'll attribute it to John Pade of Nelson and Pade. He has it, I think, on his t-shirt. And he says, right now in aquaponics, enthusiasm exceeds knowledge. He says, everybody really likes this concept, year-round food production. I can see my crops being grown locally, a protein in a vegetable crop. Sounds great, I want to do it. I mean, I get at least 6 emails or phone calls a week from people across the United States saying, I want to get into aquaponics, can you give me some information? And it's all enthusiasm driven. But on the knowledge side, we're kind of far behind. We don't have people out there that are skilled to run these operations. I know Brandon's established a crew, but it's taken you a couple of years to get that crew together. And it's quite a unique group of probably people in which there aren't many others like them around the world. So that's a stage that we're at right now. And the other comes to market, all right, or marketing the products. Generally speaking, when you're bringing your aquaponics crops to a supermarket, your chief competitor are those that are sitting there labeled organic. Right? A lot of people in aquaponics think, no, I'm going to compete with those massive rows of lettuce or cucumbers that are sitting there. You can't produce aquaponic crops at this point that can compete in the market with the mass production. It's really kind of a niche, and you're basically trying to find your own niche amongst all those other groups that are out there, such as the organic growers. I'm assuming everybody here knows kind of the aspect of aquaponics, but basically, everything from here over is recirculating aquaculture, and everything from here over is basically hydroponics. And you're merging the two together. As a scientist, it's kind of interesting to me that recirculating aquaculture has had obstacles, it has a lot of challenges to it. So does hydroponics. It's quite remarkable. You put the two together with a pipe and they seem to work. Right? And yet at the same time, there isn't much research behind it to show you why it's actually working. Right? There's also other aspects that a lot of people don't realize, and that is there's a whole microbiological aspect. I often, when I talk to people about aquaponics, say, yes, you're raising a fish crop and a plant crop, you're also raising a bacterial crop. And if they die, and they're the ones you can't see, then everything else basically just falls apart. So there's nitrification that has to take place, there's also mineralization that has to take place, and what you're trying to do here is try to pair up the types of fish that you're going to raise with the types of plants to make sure that you're creating a match in what they share back and forth. Em and I were just discussing this over lunch, actually, and that is people say, well, if you're feeding the fish all the nutrients, how does it ever get to the plants? Right? We saw a couple of presentations that already said that fish are much more efficient than cows or chickens or pigs. Well, they are, but animals overall are fairly inefficient. Right? And that is that a fish in general only retains about 30% of the nutrients that it consumes. The rest of it comes down as waste products. And that's what's being captured and basically sent over to the plants in aquaponics, is that excess of nutrients the fish didn't use. One day I was just sitting at my desk and I decided to take a look at, in some cases, what's in a fish's diet and what are the macro and micronutrients that a plant needs. And again, always trying to figure out, why does aquaponics work when you're taking two different types of production systems and plumbing them together. And if you go through the minerals that you have in a fish's diet and compare it to a plant's diet, you basically see that about 80% of them are exactly the same. And I think that's one of the reasons why aquaponics works. Essentially, boron, molybdenum, and sulfur are either non-existent or incredibly low in fish food. So the question becomes, well, where does it come from? They're trace elements, and for the most part, they come with the well water that you're pumping into the system. So they're showing up in enough quantities that the plants need. Like I said, plants need nitrogen, but they're getting plenty of that from the breakdown of the protein from the fish food. So perhaps that's one of the reasons. It's the inefficiency of the fish generating the nutrients that are shared at least 80% of the time between the fish and the plants in the system. Right? This is kind of a newer term that's come out in aquaponics, and that is coupled versus decoupled systems. Right? Coupled system is basically where the water just flows continuously between the fish and the plants. It works really well when you're raising warm water species of fish because the plants like the warm water and so do the fish. But decoupled aquaponics is really starting to grow in popularity and in systems engineering. And essentially what you do is that you run each of the systems individually, this a recirculating system, this hydroponics, and in some cases what you do, if you see these two sections here, is that you add makeup water, nutrient-rich fish waste makeup water gets sent over to the plants at a certain percentage each day. Right? Sometimes they add basically the amount that they lose to evaporation from the plant side is what they flush over to from the fish to the plants. This essentially, and this is how Superior Fresh is similarly set up, is that basically this is how you can introduce cold water or cool water fish into aquaponics without having the financial costs of trying to heat or cool the water back and forth between the fish and the plants. I like to put this up there too. I know they had one from David Love before, and that is I found some of the graphs that he produced in one of his publications surveying aquaponics to be kind of interesting. And that is that when the survey went out and they looked at the data from it, you can see that essentially, you know, how many people got started in aquaponics? The answer is most of them within the past 5 years. Right? So it's not really that mature of an industry that's out there. And then if you look at the size of the operations that they actually had, the clusters right here, which falls into what people often refer to as more of the family or farmers market size systems. Right? So the large scale systems are very rare, you know, but there are more and more coming online, and we're soon going to find out how that industry perhaps starts to change. Just additional data from his survey, and that is well, where are they located? He had the map of the US and then the map of the world. Again, they honestly said in the publication, which should always be noted, is that it probably greatly underrepresents aquaponics either in the US or worldwide. They used an email survey. And again, I generally ask the audience, how many of you get email surveys every single day, and what do you usually do with them? Usually that's what the delete button's for. Right? So their survey was well underrepresented to what's really out there, and yet it's still quite impressive when you start to see these operations across the US. I did want to throw in a couple of them. We've mentioned some of their names here. I had experience for over 3 years working with some farmers on the concept of floating raceways. Basically, as you can see here, they float in a pond. They're essentially a dock system with some plastic sheets that are in it that the water flows through. Its performance is very similar to typical flow-through systems or raceways that you see. Why would somebody want to use it? Well, we have an abundance of ponds and lakes in Wisconsin that are on people's properties, particularly on farm properties, and these lakes are basically too big or too deep to raise fish in. You'd never be able to pump the water out and get your fish back down again. So this concept went around. There was a bit of a boom and a bust period in which there were about 50 people who kind of bought into it and put these systems in place. There's still about 20 that are in operation. But basically they float in these deeper or larger ponds. You can have high density fish production because you're basically in a flow-through system. The water comes in with an airlift, flows through it, and goes out through screening on the backside. The pond itself acts as your filter, and then the water comes back in again. You can have year-round production and easy harvest. And that's kind of one of my more favorite photos when it comes to these flow-through or floating raceway systems. This is a late January day at one of these farms. Right, what I can tell you is the ice all around it was between 3 to 4 feet deep, and the temperature that day was -10. And you look inside of the floating raceways, and what do you see? Open water. Right? So you can actually get access to your fish, and you can feed them, and you can harvest them in the dead of winter right here in Minnesota and Wisconsin. And in fact, like I said, the farmer that I worked closely with, he was raising yellow perch in it. And I tend to show this graph based on the study we did. He put in some fry early in June of the first year, and they grew. And then he said, don't sample my fish in the winter, because as soon as you take them out of that water, they turn into a fish sickle really, really fast. And he didn't want us to kill his fish, and so we were just sampling them. So we kind of ignored them during the winter and then began again at the beginning of the next spring or summer to see what their second year of growth was achieved. The reason I like to show this graph is that if I put up a similar one, which is a pond-cultured perch in Wisconsin, they get the same growth the first year, and then they lose weight during the winter time because they're not being fed. The pond is frozen. And then they have to start to recover at the start of the second year. This actually has, it's very small but significant, and that is that it actually has winter growth taking place. So they're ready at this point, either in early spring to sell an advanced size stocker fish or a larger market fish at the end of the summer, because they actually attained some growth in the winter instead of losing growth. So it's kind of significant. Like I said, it's got kind of its own little niche, for growers. Most of our producers basically are just that. They're farmers. They're either dairy farmers, cranberry farmers, potato farmers, who just happen to have these large ponds sitting on their property that they tend to use for irrigation, but not much else. We've heard some talk about this, cages and net pens. As you know, right now there aren't any net pens in Minnesota or Wisconsin for growth. But cages, they're scattered throughout the various states here. They're not a primary production system for the most part. People use cages at their fish farms essentially if they're doing some polyculture, or if they want to put a predator in with prey types of fish, they'll float these cages in there for a while. Or at harvest time, they'll harvest the fish, put them in the cage, and then they can repeatedly take out fish from those cages at that point. As I said up there, you can see the different parameters or aspects to them. Obviously, the net pens kind of have the negative reputation that lingers for the past 20 or 30 years. All right, now to transition a little bit into what Don was saying, and that is, well, what about the types of local fish that we have around here, and where do we see production? Don't want to ignore this. People often ignore it because they talk about food fish, but the bait fish industry is really large. It's a main supplier of fish up here in the upper Midwest. They do mostly pond culture or wild harvest of fish. And as I said, they put them into winter kill or treated ponds so that it's a single or monoculture species that's in that pond. There's quite a diversity that are out there, but their production is closely tied to recreational fishing or use of the minnows as forage fish. So it's an industry that basically, in some cases, tries to a little bit self-regulate itself. As I put up there, they're actually the 4th largest fish industry in sales in the U.S., but it basically is a regional demand by species. I was even interested to find out that in Wisconsin, fathead minnows are king, that's what people want, and then the list kind of changes over to white sucker, and then some emerald shiners. But you come over to Minnesota, and you get spot-tail shiners that are on the list, as well as some fathead minnows and suckers. So states right by each other have just a different flavor for the type of bait that they actually want to use. Right? As I put it up there, basically the demand controls much of the supply, and as I listed up there for interstate transport, the industry moves a lot of fish around, both north and south and all across the U.S. Yellow perch, did a lot of yellow perch research, I think, when I first came to Wisconsin, and that is I would say that first bullet point is still true. The primary market for yellow perch still exists within about 50 miles of the Great Lakes. You come outside of that region and you transition into things such as walleye, or panfish, or trout or salmon or things like that. One of the unique things about the perch that you have to accommodate is that they basically produce their eggs in ribbons. And this results using a very different type of incubation system when it comes to incubating those eggs. Still, the most common method that's used for raising the perch is what is often referred to as the pond tank pond method, or some people like the slang term the green water phase. The general concept is that when those eggs hatch, the fish are immediately moved out to the ponds where they feed on the plankton that's there. When they reach about an inch in size, maybe 2 inches, they'll take them out of the ponds, bring them indoors, and they'll feed train them and wean them onto commercial food. And then they'll take them from the tanks and they'll put them back into the ponds, and then they'll raise them on the commercial food out in those ponds. Right? Very tedious or labor-intensive process, but it's still the most tried and true when it comes to yellow perch. There are some that do RAS production of perch. There's others, I know at the University of Wisconsin-Milwaukee, that say they've kind of come up with a strain of tank intensive perch. They have consistently had disease issues though. It seems once they've domesticated them, they now become very susceptible to disease. So they have to be very careful about their biosecurity. And it's very hard to get your hands on any of these indoor types of fish. There's very few farmers that have actually been able to get their own supply of them. One reason is that perch generally have a very low tolerance for suspended solids. They like really clean water. And overall, if you think about perch production in RAS, it's kind of had a bit of a storied history where you see new operations come online and then suddenly they disappear. And this cycle just seems to continue. What about perch? They have highly variable growth. Their fry or larval stage is still considered very much a black box. And that is that they're a fish with a very small gape size, which makes it very hard to feed train them. They do suffer from cannibalism and developmental deformities if you try to raise them all indoors. What has been shown is that a monosex female population tends to do the best. Walleye, I even said this to Bob yesterday, and that is I was very intimidated putting a slide up about walleye culture while Bob Sommerfeld's sitting in the audience. So I'm going to go through it really, really quickly. And that is that walleye, there still is regular production, and they utilize the pond tank pond method I talked about before. If they're going to be selling them as stockers, they'll produce them in 1 year. But if you want to do food fish and ponds, you're going to wind up doing it for 2 years. We've been working on some recirculating aquaculture production, and some of the good news is that we're getting pound and a half fish in anywhere from about 9 to 15 months. How are we doing that? Well, on the low end, the 9 months is that we're raising hybrid walleye or saugeye. This was the graph I was telling you about, Bob, and that is that we've raised the saugeye and the walleye in this exact same recirculating systems for the same period of time and observed their growth, and you can definitely see the hybrid vigor that are here. And these fish are basically a pound and a quarter after around 9 to 10 months, which are purebred walleye don't even come anywhere near as close as that. If you actually looked at that data, is after, 200 days post-hatch, these are twice the size of the purebred walleye. So there does seem to be, the hybrids are kind of like the way to go if you want quick growth. The hurdles for walleye, I think, have been consistent. And that is that some of them suffer from non-inflation of swim bladders early on, cannibalism. There isn't necessarily right now a true starter diet for walleye. People try a variety of different brands that are out there. I think the husbandry practices, Bob came up with a pretty good recipe for what you want in your system, including some turbid water, surface spray, in-tank lighting, and methods of reducing cling to the sides of the walls of the tank. Most of the places you go to, you'll hear about the fillets. I kind of put this word petite fillets up here. Last night was the first time on a menu I actually saw walleye fingers, even though I swear I coined the term about 5 years ago, so I got to talk to that restaurant at the hotel. This one was kind of interesting. I just want to throw that out there, and that is nowhere near a legitimate market survey did we use, but we wanted to gauge some industry in the state of Wisconsin about how buyers of the walleye want to use them. So we sampled about 35 supermarkets and about 50 bars and grills. And that was really quite an eye-opener to us. And that was that the supermarkets generally said that they want a nice size fillet, an 8 to 10 ounce fillet. And they said that that's what the consumer wants to buy out of the case that's sitting there. They want to bring home a fillet that they can broil or bake or put on the grill. Well, we went to the bar and grills, and we introduced them to the concept of a petite fillet, a small one, or a walleye finger. Almost unanimously, the bars and grills said, that is what we want. And I said, well, what about the regular fillet size? And they said, most of the time, they have to wind up cutting these. Right? So we stood there and kind of said, well, why the difference? Nobody's ever kind of looked into that bar and grill market, even though you travel through Minnesota and Wisconsin, and there are a lot of bar and grills. And then we realized, you go to a bar and grill, how does the walleye serve to you? Right? A little basket or cup with 3 pieces of walleye, French fries, and some coleslaw. They wanted the petite fillets, and they said, I'll buy every one that you have, because I'd rather do that than get the larger ones and have to cut them up. So again, kind of an informal survey, but it kind of opened our eyes. You really have to look at your market out there. It wants something very different. Mentioned sunfish as well. All right, these are both served as a food fish, a pan fish, as well as stocking. For the most part, a monosex males is the way that the industry is going. It takes 2 years to get a pan fish, though 1 year probably for stocking. There's a variety of hybrids that they've attempted and generally see enhanced growth with those hybrids. As I mentioned, they're primarily a pond production as well as a pond reproduction fish. There's not too much artificial spawning going on. A lot of the growers just put them into the ponds and let them make their nests and just constantly reproduce. They're a fish that in many ways can give you, if you want to loosely use the term, an out-of-season spawning process. A lot of the growers in Wisconsin tell me that between May and October, they'll get 3 to 5 reproductive cycles by their sunfish in those ponds. So they've got lots of overlap going on with different age structures. As I mentioned before, cage production is a little bit that people have tried, and here usually what they do is they have the sunfish in the pond and they put a bass or two in a cage. And generally you see some rapid growth by the sunfish as they're scared that this predator is roaming around them and could potentially get to them, so they grow a little faster. It's been tried. Not a lot of people adopt it, but they've been trying it. There's been some interest in recirculating aquaculture production of sunfish. Right? They're very adaptable to crowding as well as poor water quality. So I know in aquaponics I've been getting a lot more calls from people saying, I want to try sunfish instead of tilapia or sunfish in addition to tilapia in these recirculating systems. They accept commercial diets quite readily, and again we kind of come back to, well, what kind of diets can you have? This is pales in comparison to Steve's studies on diets, but we did one summer a study and we took a look at a diet that was the typical omnivore diet, and then we had one that was much lower in fish meal and much higher in plant meal. And this is the data that came out of it, and essentially what it showed to us was there was no difference, which is actually a really good thing. So you can lower the fish meal composition in bluegills diets and actually get the same amount of growth as you would on a high fish meal based diet. I thought I'd throw this up here as well as largemouth bass. Mostly raised as a sport fish. There's a limited live market as a food fish for them. They're generally pond raised using the similar methods as others. A little bit of nutrition research done on them, but not a lot. They tend to be slow growing, taking 2 to 3 years to reach about 1.5 pounds in size. There's a consistent, what the industry says, as a finishing growth hurdle, in which they say they get to about 1 pound in size, and then they don't seem to grow very much after that. So this is kind of interesting. They want to know, what do you need to do to kick them over that 1 pound to get them to 1.5 pounds to 2 pounds? And there's a little bit of research going into it, mostly in strain selection. And that is besides a northern and a southern, there's all these different substrains scattered throughout the US, some claiming they don't have that growth hurdle and others saying they do. So there's some studies going on right now taking a look at strain selection. And then, I know this isn't a cool water fish, but I mentioned aquaponics, so I figured I might as well talk about tilapia a little bit here. As far as tilapia goes, 4th most consumed fish in the United States, but the industry itself is dominated by foreign imports. And it's a variety of types of tilapia, and I put a couple of the more common ones that are up there. Generally, they like to raise monosex populations. They see better growth with those as well. They do very well in recirculating production. In fact, 70% of the U.S. industry raises tilapia through recirculating systems. They have wide tolerance ranges, as you can see here. They don't mind crowding. Steve mentioned a little bit, they do develop an off flavor that you have to purge at the time of harvest. And their feeding them is not all that expensive. Also, always have to throw on a little side note here on that picture, and that is do you know how many hours it took to get them to all line up and smile? And then just when you thought you had it, you snap the picture and you look at it and at least one of them blinked. If you raise fish, you would realize. Okay, again, what is your chief competitor if you're raising tilapia? It's the foreign imports. Right? Foreign imports can range from about 45 cents for an IQF fillet coming in, all the way up to about $6 for a live fish that you may be selling. That's a huge price difference that you have to convince the markets that they're willing to pay the higher price for the fish that you're raising. There's generally a separate nursery versus grow-out production systems. In fact, there are 3 major nurseries in the U.S. that supply a significant portion of the fry to most tilapia growers in the U.S. They tend to be disease tolerant but not immune. They do show a bit of problem when it comes to uniformity in size. Even when you're raising them in aquaponics, you tend to get a wide size range out of the same cohort of fish that you've raised. Again, the market's becoming a little more crowded, and one of the complaints I know Wisconsin growers have is in processing. They take them to the typical fish processors that do our trout, our salmon, or even our walleye, and a lot of those processors turn them away. They say the skin and the scales are so tough on the tilapia, it'll ruin their knives or their machines. Plus, it's a different shape if you look at it from more of those oblong-shaped fish, such as trout and salmon, so they'd have to readjust some of their auto processors that they have. So a lot of them are kind of reluctant to actually go with tilapia. So I think she's standing right there, so I'm going to say. All right, thanks.